Good morning, everybody. This morning's topic we're going to be talking about today is on FHIR and DICOMweb. So, my name is Brad Genereaux. I am Manager of Product Management at FHIR by day. I also do a lot of work in the standard space where I'm co-chair of HL7 Imaging Integration, co-chair of several DICOM groups as well on Working Group 20 and 27 for DICOMweb and for integration of imaging and information systems. Before I joined FHIR, I also spent a lot of time in the Canadian hospital IT system, doing things like implementing EMRs and RISs and lab systems, networking, etc. So kind of all over the place. My colleague here, Mohammed, he is a software engineer and a team lead for integrations and customizations at AGFA, and also works with Sim Hackathon. He'll be leading us through some of the exercises today later in the session. So, all right. So let's get started. Just to highlight, this is part of the imaging track. This is the third of 4 sessions. There's one more tomorrow on DICOM and imaging tools specifically. So by the end of this session, you should understand the concept of FHIR, how it applies to medical imaging and DICOMweb, and how it can be combined together to enable next generation workflows and solutions using medical imaging. We have exercises that we'll hand out later on as well. So how many people were here yesterday when I talked about DICOMweb? So about half. So just a short recap. So when I talk about imaging, I'm talking about diagnostic imaging, the classical radiology, where I have an X-ray, I have CTs or MRIs, but I'm also talking about evidence imaging, where we capture it for the documentation of the patient's current state, like if they've got a wound you want to take a picture of, as well as procedural imaging or point of care. So typically here it would be ultrasounds in the emergency department, where we would be capturing this imaging. We might not necessarily be reporting on that, but we still need it as part of a procedure. And we want to take these images and image-enable clinical reports with it. So, in looking at enterprise imaging, so this is kind of all-encompassing. It's a set of strategies, initiatives, and workflows implemented across the healthcare enterprise to consistently and optimally capture, index, manage, store, distribute, view, exchange, and analyze all clinical imaging and multimedia content to enhance electronic health record. Very important for all of the different use cases where we see imaging. Imaging is worth 1,000 words, a little bit cliche, but obviously if you have the imaging, text is good, but text with images are better. That was a paper you could read from a long time ago. A Google mantra: if I can't find it, it does not exist. Not very good if you're looking for your favorite sports team or something like this, but if it's patient's imaging, bad things come of it. If you have to re-image the patient, they're put at risk for increased radiation, or also getting hospital-borne infections like C. difficile, that sort of thing. It costs more. It causes discomfort and anxiety, like if they have to get injections or move in certain ways. And it delays the patient because they have to be re-imaged, and it could also back up the healthcare system as well if they have to re-image a bunch of patients that they didn't need to. If you look at a very simplistic imaging department workflow, the patient comes to the clinic, the doctor creates an order, the order gets reviewed, the images get acquired, a report is written on those images, and then the results are distributed. But we see that these things are evolving and becoming more and more complex with this move to patient-centered care, looking at enterprise imaging, leveraging mobile devices and apps like bedside terminals, looking at how do we move these things up to the cloud, looking at the cost and making sure that we're delivering appropriate care by using these imaging, and then also looking at how we can use compute power on advanced analytics. So what is DICOM? It's imaging, right? So it's a standard for handling, storing, printing, and transmitting information in medical imaging. And it consists of both a file structure as well as a communication protocol. And if we look at the hierarchy, how DICOM defines imaging studies, you have a patient who has a number of studies. Each study has a number of series, and each series has a number of instances. And these instances all contain a whole set of metadata including details about the study, like the date of the study, the description, the referring physician, the accession number, the series information, like what modality, what device was it acquired on, as well as the description, what body part was imaged, and then the actual images themselves and things like the height and the width of the image, as well as the position of the patient on the table if they're doing a CT scan. So, looking at how FHIR relates to medical imaging, which is really important, because we think about, we have FHIR, and how does this cross into the world of imaging? If we look at the synergistic relationship between HL7, DICOM, and I would say documents as well. What comprises of the full clinical patient record is the discrete data, the imaging data, and the supplementary documents like requisitions, order notes, those sorts of things, discharge summaries. And we've got a number of standards that have evolved over the years to actually capture this. So in HL7 we had version 2, which is in 1989. Version 3 came out later, and then FHIR later than that. In DICOM, we had the first official spec of DICOM in '93, WADO, which is web access for DICOM, 2003, and then DICOMweb started in 2011. And then in terms of documents, CDA has been there, XDS, and we've always had things like PDF and TIFF and others. So when we use FHIR versus when we use DICOM and DICOMweb, FHIR is geared towards information-centric workflows. So your EMRs or EHRs really to discover the existence of studies and work with all the supplementary data like orders and reports around that. And we use DICOM and DICOMweb when we're looking at the imaging-centric workflows. The modalities produce DICOM. They have for 20, 30 years. The PACS consume DICOM data and store. The VNAs consume this as well. Store and allow for retrieval. The advanced visualizations will use DICOM. So looking at where things sit on the spectrum would dictate which of the standards you use. But we've worked together, both HL7 and DICOM, to make sure that these things are in alignment between what we've done with FHIR and what we've done with DICOMweb. So the two groups are HL7 Imaging Integration and DICOM Working Group 20, and it's the same chairs that govern both. So I'm one of them, and then my colleague Elliot Silver, who's part of Change Healthcare, formerly McKesson, guide these two groups. So why would we not just use FHIR? Why don't we just move to FHIR? DICOM has been one of the most widely deployed healthcare messaging standards in the world. Hundreds of thousands of modalities are producing these images, and they're there for the long haul. It's not like a mobile phone that you go through every 2 or 3 years. Someone will buy this and it sits there for 20 years. And they're not really easy to upgrade. 2 trillion images are produced annually, 450 petabytes per year, doubling every 5 years. And right now, globally, there are 4.5 exabytes, which are 1,000 petabytes, 1,000 of those gigabytes, right? So it's a massive amount. There's not a lot of value, need, or industry support to be able to switch to a new standard tomorrow, as an example. So looking at imaging study in FHIR. Here's for the time check. I don't want to go too long here. So recap, right? So we went through that kind of the workflow. If we were to map that onto FHIR objects, we'd look at the the visit, order, protocol, acquire, report, and access. Those are our use case steps. And if we look at the FHIR resource we'd use to do these things, we start out at the encounter or episode of care for the actual recording of the visit. The order for the exam would typically be a procedure request, but it could also come in as a referral request or a care plan, depending on what's being used at the hospital. We'd use procedure requests to dictate the protocol. So for example, if it's a CT with or without contrast. Then we acquire images, and this is can be documented using the procedure. The report is written using diagnostic report, and then imaging study is what's used to record the existence of that study that we communicate to other systems. So imaging study looks a lot like this. If you look at the FHIR spec, there's one main object, which is the imaging study, and then it comprises of series like I showed, and then each of those series has instances. Very simply, if I were to do a query using FHIR, I would just pass along something that looks like that. What studies do you have for John Doe? And then I get back a response of the studies that are available for him. Looking at a JSON representation, you can see that, so this is not a complete example, but the most important parts, I mean, for me at least, are the study, series, and instance UIDs, which I've bolded there. Those are those URN OID numbers that reference each of those different levels. But you can see things like the date timestamp, the patient reference, where I go to get to the study. Actually, I'll step through a little bit. So looking at the base instance, you can see that we've got the study instance UID, the list of modalities, whether it's CT or MRI, the account or visit reference, the order that it was based on, who read the study, where to go get the study, why the study was performed, the accession number, obviously the patient and timestamps, who ordered the exam, the type of procedure it was, and then we also have a free text description of what the exam was. Looking at the next layer down, we've got the series, which contains the instance UID as well, the modality for the series. So if you did a CT MR combination as an example, it would be that particular series, that run of images. The description of it, where to go get it, what part of the body did it come from, and if relevant, what side of the body. So if it's arm, it's left or right. And then instance, there's not a lot of detail here, but basically you'll see the instance UID as well as the type of object. If it's a JPEG, or if it's a document, or if it's something else, that's referenced by the SOP class, the Service Object Pair class. Special mention of the endpoint resource. This is our connection between the FHIR and the DICOMweb worlds. This will tell you where to go and get the imaging study. So you can see that we've got the connection type. And there are a number of different types that have been defined. WADO URI, which is the classic or legacy WADO retrieve, which is what most systems support today. WADO RS is the RESTful interface to this. TIDO is a way to query to get more detail about these objects. And we also have IID, which is a profile that IHE describes that allows you to launch a zero-footprint viewer to visualize those images. And then the base URL, the address, is where you can go and get start with the service to actually construct the URL. So we would take the address, add in the study series of instance UIDs from the imaging study objects, and we create a full URL, and you go and grab those images right away. So looking at kind of, we put it all together. This example that I created, I showed actually last year, which is a get study thumbnail. So again, we've got some, here is our imaging study resource from FHIR. We pull those things out, we can construct a WADO RS call. I added a couple of extra parameters, so viewport equals 50, 50. What that allows me to do is say I want the image very small for a thumbnail, 50 pixels by 50 pixels, and I'd like it as a JPEG, and I get back an object, and I can then put in my EMR and actually show, here's the image that represents the study. There's lots of caveats though. Indeed in a basic use case, you have to think about security, obviously, and also that my thumbnail is relevant. So if you imagine if you had a CT series here, if you grab the first image and it's of the guy's head, you're going to get the very, very top of the head, which is not very indicative for a clinician. They wouldn't like that. They would much rather see something like that. But DICOM, we're working on a thumbnail API right now, where all you have to do is say the study/thumbnail, and it will give you a thumbnail that you can use to embed inside the EMR. It's almost part of the specification, but not yet. Yeah?
While fetching the images, we can specify the compression factor, or is it possible?
Yes, yeah, you can also specify the compression factor. So you could request lossless, or you could request lossy, and you can specify the Q factor on how lossy you're willing to accept that. Yeah?
So is this a DICOMweb feature or a FHIR feature?
That would be a DICOMweb feature. Yeah. So when you make the WADO call, one of the other parameters you can put on is the quality. It's just another parameter that you can put on for that. So here, image enabling reports, right? If I have an EMR in my image cache, I layer on the standards in FHIR and DICOMweb. I can ask the FHIR for to grab a report as a CDA, and then I can use DICOMweb to retrieve the associated images and actually build out a report like that where I've got the text and the image side by side. I can enable richer work lists. So you think about while we're acquiring images from a patient, I'm using Google Glass, which might have fallen a little bit out of touch since then. But here, I've got a patient ready to be scanned. Having the details about the procedure on hand is incredibly valuable. So I can learn about what patients are on my work list, and I can use FHIR to go out and enrich that to actually get more data about the patient that might be relevant as I'm going to image the patient. If I were to look at analytics, which is really the next generation of, in the imaging space, it's the current hot topic. Looking at images themselves, we've been doing for a long time, like looking at a CAD, say, oh, we've got this great circle detector in for CT studies, looking for what could be lung cancer. Enriching that with FHIR data adds an incredible dimension on actually analyzing these images. And we can do a much more refined job of picking up conditions by combining both the imaging with the data about the patient as well. So with that, let's look at some exercises. So I'll turn it over to Mohammed. I have some exercise worksheets that I'm happy to hand out. Who wants one? Russ, not here. So there we go. There we go. Yep. There we go. Awesome. Pass one down to your neighbor. Oh yeah, sure.
Thank you.
You're welcome.
All right, so for those of you who have not done any of the exercises with us yesterday, I'll be using a tool called Postman. And excuse the image there because I left over from yesterday. We're going to get there today at some point. Postman is a nice tool for testing web APIs. I've used it before, but if you're hardcore and let's say like, I don't know, Perl, by all means, have fun. Anything will work here. The other thing you'll notice, was there a copy left?
Nope.
Oh, they're all done, okay. Exercises are getting popular. I'll bring up my screen copy. One thing, that's okay, I'm good, thank you. I've got it right here. So I'll just highlight this one thing. So we are using a server today that is hosted in the cloud by the SIM conference. And this is a conference in North America who's graciously agreed to share the server with us today. We're all going to be using one single API key. That API key is only valid until about tomorrow, whenever I actually get around to deactivating it. Afterwards, if you'd still like to use the server, you could do so free of charge, but you will just need to get your own API. That's all they ask. If you need to get an API key, get in touch with me and I'll help you out. Okay? So yeah, feel free to keep using this one until tomorrow. It should work just fine. That being said, I think we're going to proceed, but just one more disclaimer. There are a lot of cool potential tricks that you can do with FHIR and DICOMweb that Brad has talked about in his presentation. Unfortunately, a couple of the coolest points don't actually work. So just giving you an advance so you're not disappointed. I don't want you throwing tomatoes or eggs at me. The two things that don't work, unfortunately, right now is we actually just switched the FHIR server implementation, and the new one isn't properly set up, so things are not working right. So, for example, that link that Brad was talking about, the address element that takes you from FHIR to DICOMweb by providing you with the actual URL for DICOMweb, that isn't working on our server. But it's okay; we can still find our way around it. So that's one thing. And then the other one is the thumbnail API is actually new and hasn't been implemented yet, so our server doesn't have it. but we will be able to get a JPEG rendering if you could tell it which frame you want within the study. Last but not least, I should just mention this before any of you start getting headaches with these URLs. When you see a long URL like this, I should have pointed this out yesterday, you don't actually need to type this entire thing. This is something that we'll find in the response. You can just copy it and paste it, and I will show you that in just a moment, okay? All right, so let's get started. So the first thing we're going to do is we're going to try and find a patient by it says by name, but in this case we're actually doing it by their ID, okay? So we have a patient here. We know their ID is called Genereaux. Now, in real life, you probably will want to search by patient name using an example URL like Brad showed. That unfortunately isn't actually working on our server. That's one of the reasons we're doing ID. That's the problem with being on the cutting edge of technology. Like, we're trying to update these servers, but things break all the time. So I will paste that URL, and again, ignore the image. This is left over from yesterday. All I'm doing here is putting in the URL, and I added a header, which is the API key. There is a second one here, but this one is not activated. There's no check mark next to it. So it's really only this API key header right here. Okay, I'm going to hit send. Okay, and then in here, what you're seeing is, dissect this. So of course it's telling me if my resource type is a patient. I asked for a patient. The ID is Genereaux, and it's giving me a little bit more information. So again, usually in FHIR you'll get this text field, I guess. Like, this is what it thinks is the easiest representation if you've got, let's say, a web application. And then afterwards gives you more information about the patient. In this case, this is using the Sim Hackathon dataset. This is a synthetic dataset, but it's also meant to reflect real-life patient vignettes. So they all have the last name Sim to make it obvious that it's synthetic, but then they have names like Joe and Andy and I think Sally is another one. So they all have plausible real-life stories. You know, like for example, Sally is a breast cancer patient. I don't remember the exact narrative behind Joe, but that's actually available on the web. You got some information, of course, here, okay? And then usually what will happen is, usually down below, you may actually get a list of their imaging studies. That depends on the implementation. Some servers will offer that up front. Some servers actually require you to dig in and get that. And that leads me to yet another thing that doesn't work. In theory, you are supposed to ask for imaging studies giving patient ID. On our server, that actually stopped working after the upgrade. We'll have to figure out what happened there. So for now, we're going to pretend like we actually know the identifier for this study. And in my case, that identifier is really the accession number of that study. Okay? Just a quick plug for the Sim Hackathon dataset. One of the reasons why I like to use it for this is because forget about the issues with the server, but the actual dataset is a dataset that lines up very nicely between FHIR data and DICOM data. So you can go all the way from FHIR and find your way down to imaging and get those studies. The accession numbers actually line up between the FHIR information or FHIR data and the DICOM web data. So that's the nice thing about it. Okay. Oh, and of course, the data set is also separate from the service. The data set is open source on GitHub. You can go take it, install it on your own FHIR server, your own DICOM server, test with it, play with it, contribute if you can. It's actually developed by radiologists, so that's one of the reasons why it's very realistic. Okay, now let's take this and actually see some information. So, I've only done one thing here. I've replaced my URL at the very top, and now I'm using the imaging study URL. Okay, so let's do a send on this one. So in here, again, it's relaying the information to me that I'm asking for an imaging study resource type. There's the ID. Again, the ID lines up with the accession number and the DICOM. Let's go down. There is the study UID. So for those of you who are going to try and follow me along, if you want to construct the URL, you will want just this part of it, just where the numbers begin. Okay? You don't want the prefix. You don't want the part that says URN OSD. Of course, there's always the linkage back and forth. So here it's telling me, you know, which patient should I ask for if I want to go up the ladder back to the patient. Of course, in this case, we're going the other way. Yeah, go ahead.
I have a question regarding the ID. So is it the normal way, or is it a standard that you should use the extension number as an for the fire service, or is there any guideline? Imagine that the extension number is not
The identifier.
and all, I mean, not the next sentence,
Yeah, from my experience, it is the norm. Brad, do you know if it's something in the standard?
So from a FHIR perspective, because you think about more on the information system side, it's more geared around the order number, not the placer number, right? So it's the placer number if you think about the HSM order. So it's not globally unique. It's not even the study instance ID, which would be globally unique. But typically, because of the way the FHIR specifies identifiers, they specify the issuer of the accession. And so at least with that combination, they should be unique. They better be unique. That's the whole point of doing that.
I can tell you another thing I've also seen is a lot of servers don't actually let you specify the ID as much as they will just generate one for you. And they'll usually use like the UID generator, the one that looks like, here, I'll bring up one example.
Oh, the Microsoft.
One of these, that's a common implementation I've seen. So here's an example of what it would look like. A lot of the servers I've seen do that, but you know, some enforce it, some don't. I don't know how detailed the standard is in that area. My experience is a lot more practical than theoretical. So going back to the imaging study here, within the imaging study, you'll notice that it also begins to list the series within the study. I'll be honest, I'm an imaging guy, so when it gets to series information, I'd rather be looking at the DICOM anyway, and that's what we're going to do next. But just a reminder, if you scroll all the way up and you look for the UID field, you'll want to copy this for the next part of the exercise, okay? And one other thing I'll also point out, remember when I said that link between FHIR and DICOMweb should be here, but it's not on the server? So yeah, usually you'll see somewhere in this area an address field, which will say, you know, DICOMweb RS or DICOM RS, and then it will have the link sending you directly to the DICOMweb server. If you actually look at the raw data, the JSON data that we store in GitHub, you will see that we are pushing it in, but for some reason the server decides not to show it. Sorry, question?
I was expecting to find list of modalities, or is that optional?
I think this one has it here per series, because modality.
At the series level you have the modality, but at the study
At the study level, yeah.
list of modalities.
That's a good question. You know what? Let's see if we can actually take a quick look. We actually are good on time, so let's see. Let's take a quick look at the GitHub repository and see.
We have 10 minutes.
Yeah. So if you go to the SIM repository, by the way, there's the hackathon dataset, and this is the FHIR dataset, and then there's the hackathon images, and that's the DICOM dataset. Okay? The two line up with each other. Let's take a quick look. Now, which patient are we on? Genereaux.
I guess it can be reconstructed by going through the series.
Right, yeah. It is a field at the study level, but maybe this data set didn't have I think it is optional at the study level, but it's mandatory at the series level.
I was explaining.
But sometimes it is on instance level. So there can be a series with images of different.
No, it is forbidden.
We have seen that.
That they're committing a DICOM crime.
Call the DICOM police.
Yeah, no, it's
It happens.
I believe that it happens. I've seen lots of bad DICOM.
Yeah,
No,
people
that-
put OT kind in
Yeah,
the same
well,
series as
OT.
images.
At the instance level.
Yeah, you can have different object types in the same series, but the modality that OT modality would apply to all those objects. So you could have reports and images in an OT series,
Yes.
but the whole series would have the OT as the modality, at least it's supposed to. Because if you don't, then that's a big trouble. know that one in particular. So,
Since I opened up GitHub and I'm actually showing you the raw information, just say believe me, the URL is actually in there. But I think that the new server may actually be picky about it being called an address rather than just being called the URL.
yeah, no, you know what? The reason why it's because it's not SQ3 compliant yet. That's why.
So
Because
it's
it's using
full
endpoint.
structure. Yeah.
Yeah. And so we used to have URL, but in SQ3 we did away with it because if you think about, we had URLs at the study series and instance level. If you had a 10,000 slice CT study, you would have 10,000 gargantuan URLs. And if you're just wanting to know study discovery, that's 90% of what you get back. So we got rid of all of that and just used endpoint to say, here's where the server is. You can construct your own URLs depending on what your needs actually are. So that's why we have to work on that.
I'll have to fix that, yeah.
Yeah, so good, okay.
Yeah, I've got homework. Let's go back and try this out. So again, you can copy the UID from the previous response. I will just take the shortcut and do the whole thing. Oh, and of course, I should also mention, our FHIR server defaults to returning in JSON. But of course, the trick is, I'll go back for a second here, is if you want to switch it to XML, you can just switch to, let's say, text XML. And there, everything comes back in XML. So it comes down to your preference, really, whatever you like. I'll probably keep it with XML just because it looks a little bit nicer. A bit more readable. Oops. What did I? Slash. Oh yeah, the slash instance, that's what we need.
Also, you probably don't want the, oh wait, yeah, no,
Yeah.
sorry.
Right now we're just looking to discover more than actually retrieve. So yeah, when I say slash instances, that means tell me about all the individual objects in that study, and typical DICOM fashion, everything comes back as a multi-part HTTP response. So again, remember, if you're parsing that, you kind of parse it. In Java, you have to use like mail library to actually parse multi-part. If you're using another language, I'm sure there's another way to do it. But yeah, there's information. So this is not a very big study, which is why you don't have a lot of information. But if it was bigger, you get very long responses. If you have 300 instances, you probably have 300 parts to the response. Okay? So going back here, so we're on step 3, or we've just provided this request. Are there any questions or any problems? We still have about 5 minutes. We'll do the bonus.
What happens if the customer changes his VNA vendor? The URL has to stay the same.
The URL would change. What you could do if you have the link from the FHIR to, you would just update the FHIR information, right? You should put request to the FHIR server. You can update that one thing.
You have to do it for each study.
In theory, yes, but I mean, the reality is if you did your homework there, what you probably would do as a customer is your URL, the host name part, to the VNA would actually be a virtual IP, so you could point it to the new one versus the old one. That's
So you
really the
keep it
easiest way to do it.
There's tricks for that.
Yes, that's like more on the IT side rather than on this side.
The paths can change.
So what's that?
The path can change.
Hopefully not, but I mean, and more often than not, you can also put a proxy in between to do the redirection.
302.
And it's not too bad. I can tell you, like, this is actually, for example, the trick with a SIM server is that there's a proxy in between, so that even when we change the underlying implementation, our URLs actually stay the same. Yeah. And we've swapped the internal servers, we've swapped the DICOM server, we've swapped the FHIR server before, and the URLs work. Of course, some features break, but the URLs are still the same.
So is there any reference from the DICOM server to the FHIR server? Like, are you storing some URLs in the DICOM server?
No, not easily. I mean, you could look by patient ID and things like that. Do you know of a better link, Rob?
No, I mean, you could use the identifiers to link back and query in FHIR again, but there isn't a way to say, here's the FHIR server that you pulled the DICOM from, kind of thing. Because you think about DICOM, they're all files on disk, and they're not as, usually there's a relational database to kind of help index these sorts of things, but they're mainly files. And so that pointer back would be difficult to describe because it's a little bit more dynamic. So you probably wouldn't see that. But you can always search back and get the information if you knew where the FHIR server was.
So would you think that kind of like a gateway where you abstract all this FHIR and that DICOM thing will be helpful? Because it seems like if you have a system that is accessing DICOMweb and doing some modifications on the images, that whenever updates FHIR, then the data can easily get out of sync, right? And how do I resolve that problem?
That's a good question. A really good example would be what if the patient name is changed on the DICOM objects. The DICOM object would, a lot of the times you don't even update the files on disk. Usually it's only when it gets sent out. But that's something that services that layer on top of it would rewrite the DICOM header as it's sending out that file. So there's definitely a lot of cases where they'll fall out of sync, and that's kind of the reality of how DICOM package up their files with this metadata embedded within the image itself.
Because I mean, if you were proactive about doing updates and writing them to disk right away, you could encounter some pretty serious performance issues. Because you have to remember that with DICOM, part of the reason why it's complicated is the sheer size. A lot of these studies are gigabytes, and this is like one study for one patient. Imagine when you have so many thousands of studies and how complicated these things get. So you have to be a little clever and careful with how you treat the data there. So you had a question?
Well, just a simple one. So can we get JSON for DICOM data as well?
Yes. So both FHIR and DICOMweb speak JSON and XML fluently. It's your choice which one you prefer.
Well, I tried adding JSON to the header, but it still returns XML.
Some of them can be picky. You could try text, JavaScript, or application/JSON. It should respond to one of them. If it doesn't, let me know. Yeah, go ahead.
So I really like it and see the potential of combining both. I have two questions, one for now, maybe one to discuss afterwards.
Sure.
The setting where I'm working in is radiotherapy, and we're using a lot of DICOM also for the treatment itself, actually.
Yeah.
What about, for example, if you delineate and create an archistruct? And is it possible to extend currently this standard to say, in the FHIR report, we're also getting which structures were delineated, for example, or have such custom tags which are maybe nested deeper into the images to get that in the FHIR standard? Because I think that's where we would be interested to see if we can get that into FHIR.
Definitely, you can profile the imaging study resources to extend that should you need to do that.
Yeah.
DICOM, you can also use private tags, but it definitely can be done. You have to do the wrap up.
Yeah, we'll have to wrap up, so we can talk afterwards. For those of you who are interested in trying the last one where you actually get to see the image, it's the same image you originally saw on my screen when I said it was left over from yesterday. Again, the identifiers could just be copied from the responses. And I'll be around today if you need me. I'll be more than happy to show you in more detail.
Let's go back to the slide really quick. Yeah. And we'll do that really quick. And you can find us at the imaging table. Oh, so yeah, that's not. Fly to this conclusion really fast. Right, so FHIR and DICOM complementary services built to meet the needs of patient-centered care, modern web architecture, security protected, backward compatible, and forward thinking. Find out more information on the DICOM standard there, and also imaging study is our main FHIR resource there. If you're really interested, get involved. So join us in Working Group 20 and also in imaging integration. You can join the mailing list, they're free. You can join the calls for HL7 as well. Special thanks to HL7 and DICOM and subsidiaries, as well as my colleague Elliot for content for these slides. Join us again tomorrow at 9 a.m. to talk about DICOM and imaging tools that Mohan will be leading. And that's it. Always, come find us. We'll be here for the rest of the show. Tweet at me, follow me on LinkedIn. I'm happy to interact on any of these things anytime. I love imaging. So thank you very much, everybody.